Bismillahirrahmanirrahim. Assalamu alaikum dear students. Today we will discuss about long question 5 and dative covalent or coordinate covalent bond. And it is somewhat different from previous bonds, covalent bonds and ionic bonds, ionic bond formation and covalent bond formation, because dative covalent bond and coordinate covalent bond, in this type of bonding only the bound pair of electron. We know that in ionic bonding electron transfer take place, from one atom, electron transfer from one atom to another atom. In covalent bond, mutual sharing of electron take place and bond pair is formed. But in this type of bonding, bond pair of electron, whole bond pair of electron to whole bond pair of electron is shared by one atom only. It's mean one atom donate electron to the other atom. This type of bonding is called coordinate covalent bond or dative covalent bond. First heading is the definition. We are starting from here. Coordinate covalent bond is a type of covalent bonding in which the bond pair of electron is donated by one bonded atom only. Then heading is donor atom. The atom which donates the electron pair is called donor atom. And then heading is the acceptor atom. The atom which accepts the electron pair is called the acceptor. Then the heading is representation. A small arrow is usually used to indicate the atom and bond pair of electrons being donated. The head of the arrow is towards the acceptor atom. Listen girls, here is the example of coordinate covalent bond examples. First example is formation of ammonium ion coordinate bond, and you can see here that when it is formed by the combination of the ammonium, we will discuss about the formation of ammonium ion coordinate bond. It is formed by the combination of the ammonium molecule and a hydrogen ion. In ammonia, the nitrogen atom has a lone pair of electron. After completing its octet, it donates this lone pair to the hydrogen ion. We know that nitrogen have five electron in its outer shell, in which it will share 3 electron with hydrogen atom, and it will complete its octet. And the lone pair which are present in the ammonia will act as a donor. And when an atom with deficiency of electron will approach ammonia, and any atom which have lone pair of electrons, it will donate the electron to electron deficient element, and in this way they will form coordinate covalent bond, and it will form a stable compound and will convert into and form a stable compound. So what is the condition for the formation of coordinate covalent bond? There will be two conditions. First condition is electron deficient molecule, and the second is the electron with the lone pair of atom with the lone pair of electrons. So if for example, if a electron deficient atom will go towards the molecule and approach the molecule with no lone pair of electron, the bond formation will not occur. The bond formation will occur when one atom have extra lone pairs and the other atom will be the deficiency of electrons. Then the atom with extra lone pair donates electron to the electron deficient element and form a coordinate covalent bond, because ammonia donating the electron to a hydrogen atom. That's why you can see that arrow we represent the coordinate covalent bond by arrow, and the head of the arrow towards the hydrogen atom and the tail of the arrow towards the nitrogen atom of ammonia, because nitrogen is donating electron and hydrogen is accepting electron. That's why a lone pair is shared by one atom only. So this is the type of bond which is called the coordinate covalent bond or dative covalent bond. And here is the next heading, formation of ammonium ion. And first heading is lone pair. The non-bonding, and it is also the short question, what are lone pair? So The non-bonding electrons pair available on an atom, like the one available on nitrogen in ammonia, is called a lone pair of electron. This is the short question, what is a lone pair, and the heading you can also write here, heading lone pair, and then second heading is formation of ammonium ion, which is starting from here. When a proton approaches a molecule with a lone pair of electron, that lone pair is related to hydrogen and a coordinate covalent bond is formed. For example, formation of ammonium radical. So you can see here that nitrogen have extra lone pair which are present in 2s2 shell, because electron has 5 electron in outer shell and 2 are present in s2s2 and 3 are present in 2p, and these 3 electrons are shared by hydrogen, and it's why complete its octet by sharing with hydrogen. After completing its octet, it has extra lone pairs which are present in the 2s subshell, 2s2. So these non-bonding electrons and lone pair of electrons are shared by nitrogen with the hydrogen, which is the electron deficient element or atom. That's why they will form coordinate covalent bond by donating and accepting electron. And here it is the nitrogen, and ammonia is the donor and hydrogen is the acceptor. And here is the second example, formation of boron trifluoride, main heading. And next is the explanation. We have to draw this diagram also, and there are dot and cross formula, and same elements have same cross, and you can see here in ammonium formation, nitrogen, we will represent the electrons of nitrogen and outer shell electrons of the nitrogen in with the dot and cross, and outer shell electron of hydrogen will represent with cross. And listen girls, why we represent only valence electrons by dot and cross formula? Because we know that only valence electrons participate in a chemical reaction, and inner electrons, because are filled, inner shells are filled, that's why they are not participating in any chemical reaction. That's why we will not write the number of electrons in these shells, and we will represent only valence electrons in an atom, and these because only valence electrons are involved in chemical bonding. So next is formation of boron trifluoride, and here is an example you can see here. This is a formation of boron trifluoride, and formation of boron trifluoride or formation of bond between boron trifluoride and ammonia. In this ammonia, in the first example, ammonia donates its donated extra lone pair to the hydrogen atom, and in this example, ammonia is donating hydrogen to the boron trifluoride. Boron, and because it shares electrons with 3 fluorine, that's why we call it boron trifluoride, and its mean 3 fluorine are combined with boron atom. So what is the chemistry? Boron have 3 electrons in its outer shell. It has atomic number 5 and 3 electrons. It has 3 electrons in its outer shell, and it requires 5 electrons to complete its octet. First, it will share 3 atoms with the fluorine, 3 electrons with fluorine. Now we will talk about the formation of coordinate covalent bond between ammonia and fluorine. First, we have discussed about the formation of coordinate covalent bond between the ammonia and hydrogen atom. electron deficient hydrogen atom in which ammonia donates its extra lone pair alpha electron to the hydrogen atom, but in this molecule ammonia donates its extra electron or lone pair of electron and bond with boron. Boron has atomic number 5 and it has 3 electrons in its outer shell, and it requires 5 electrons to complete its octet. First, boron, you can see here that there are 3 single lines. First, because boron has 3 electrons in its outer shell, it will combine with the 3 fluorine atom and it will share these 3 electrons with fluorine atom. And now after sharing of electron with 3 fluorine atoms, it has 6 electrons. You can see here 1 2 3 4 6, because it has 3 bond pair, single bond pair with each fluorine atom. That's why it has 6 electron. First it have in ground state it has 3 electrons, and after it, when it combined with fluorine boron, it will have 6 electron, and still it require 2 electron to complete its octet, because after reacting with fluorine, now boron still have deficiency of 2 electrons. So these 2 electrons will be donated by nitrogen, because it has lone pair of electrons, and these electrons are donated by the nitrogen to boron atom, and in this way boron will complete its octet by accepting electron from the ammonia, and a coordinate covalent will be formed. So here it is the in the formation of boron trifluoride and molecule, the valence electron of boron atom pair up with 3 electrons and form each 3 fluorine atoms. We know that fluorine have atomic number 9 and it has 7 electron in its outer shell, and boron have 3 electrons in its outer shell. And when they will form, and because fluorine will require only 1 electron, and if it will form, it will share single electron with boron and will form, and 3 fluorine will form boron trifluoride. After this sharing, boron still have deficiency of 2 electron, which will be provided by the ammonia, and here it is, you can see here the coordinate covalent bond will be formed between ammonia and boron trifluoride. And here is the explanation of this, the bond formation, and which I have already explained that there is the 2 condition. There will be the 2 condition for this bond formation. First, the one atom should have electron extra lone pairs, and the other atom should be electron deficient. And that's why when electron deficient molecule will approach the molecule or atom with have more lone pair of electrons, then a coordinate covalent will form. For example, one molecule in the formation of boron trifluoride molecule, 3 valence electrons of boron atom pair up with 3 electrons, one from 3 fluorine atoms. The boron atom, even after this sharing of electron, covalent bond formation still remains short or deficient of 2 electrons in its outermost shell. Now, if a lone pair approaches this molecule, it accepts lone pair from that donor and form a coordinate covalent bond. The lone pair of nitrogen of ammonia molecule makes it a good donor and good donor molecule to form a coordinate covalent bond. So existence of lone pair in any molecule will make it best donor and a good donor, because it have extra electron and it will donate electron, its extra electron to any molecule with deficiency of electron, and in this way they will form coordinate covalent bond and they will form a complex molecule and stable molecule. So here is the long question 5, and our final term syllabus completed, and now we will start our revision. and learning. Okay, Allah Hafiz. Have a good day.